Hello everyone, this is your Cisco trainer and I welcome you to part 6 of lecture 6 from the course CCNA 200-301. It is 100% completely free course to pass the CCNA exam 200-301. And if you like the video, leave a comment and share to help spread this free series of videos. And if you haven't yet subscribed to my channel, stay tuned please by just clicking on subscribe button, thumbs up, hit the bell icons, and do not miss the upcoming notification. And in today's lecture, I'm talking about what is Fixed-Length Subnet Mask, advantage and disadvantage of Fixed-Length Subnet Mask, solving some questions according to given topologies, answer to given subnet questions. Now let's jump and start. A fixed-length subnet mask FLSM is a sequence of number of unchanging length that streamline packet routines with the subnet of appropriate networks. A subnet can be geographical defined local area network LANs. A subnet may define security boundaries, departmental boundaries, multicast zones, or hardware security parameters. Once a packet has arrived at the organization's main gateway, it is network numbers. That packet is routed to its unlimited destinations using a subnet numbers. The FLSM is usually a string of binary digits showing over the subnet numbers, telling the routers which part of the subnet number to look at. A binary ones over a particular digits in the subnet number says, pay attention to these digits. A 0 says, ignore this portion. So in this scenario, we have 5 VLANs or departments. Each department has its own IP. We have 5 LANs: LAN A, LAN B, LAN C, LAN D, and LAN E. Each has an IP address. LAN A needs 30 hosts, LAN B 30 hosts, LAN C 28 hosts, LAN D 20 hosts, and LAN E 18 hosts. So why we say a fixed-length subnet mask? These 5 LAN have same or equal subnet mask. So one subnet mask is convenient for all 5 VLANs or local area network or department. You can call it department, geographical area networks, departmental boundaries, security boundaries, or multicast zones or hardware security parameters. So we can use one subnet mask over all 5 departments: 255, 255, 255, 224. So this subnet mask is equivalent to all of fixed-length subnet mask usage. The use of an FLSM save routers the task of having to handle an entire IP address because the router deals only with the digits selected by the mask. Nevertheless, this method of subnet masking can result in inefficient use of IP address space because subnets are rarely filled to capacity in network having many unassigned IP address. So in this case, we solve this issue. The VLSM is CAM, Variable-Lenght Subnet Mask. It is sometimes called single-size subnet as well. In this topology, we have many departments. On left-hand side, the LANs are need 200 addresses, but on the right-hand side, the LAN needs 50 addresses each. So it is really difficult to outcome with because we have a lot of IP waste in such a diagram. If we go with a FLSM, a single size subnet, operational simplicity is a matter. FLSM is not well structured for an organization. The big disadvantage for using a single size subnet is the waste IP address. We have a formula. To the power of 7 minus 2 is equal to 126. So it is less than the requirement which we have given. To the power of 8 minus 2 is equal to 254. So it is good for our requirement, but we have lots of wastage. Each LAN has 254 IP address. So that's why we're not using a fixed-length subnet mask. If we overcome with these issues, so FLSM is CAMs. In the next lecture, we will talk about the VLSM, subnet questions according to given topology. Cheat sheet is a very good tools for our network engineers. If you want to solve subnet questions, you have to memorize a cheat sheets. Here we have 2 VLANs. VLAN 100 and VLAN 200. VLAN 100 needs 19 hosts, VLAN 200 needs 29 hosts. Now let's check the cheat sheets. How we find the column which is really fit or convenient to our requirements. We're talking on a fourth octet, or we are locating at the fourth octet of the given IP address 192.168.0.0/24. So I have changed the first 3-bit of a binary to 1. It means we borrowed 3 bits. The place value of 3 bits are 128 plus 64 plus 32 is equal to 224. The group size is 32. Now if we want to find the subnet's address, we just start by 0 and increase it with 32 until we pass the target IP address. 192.168.0.0, 192.168.0.32, 192.168.0.64, and so on. So now we defined and specified or determined the network IDs. With 2 to the power of 3, we obtain 8 networks, but we just needed 2 of them. How we define the first usable address? As I told you before, just add 1 to the network ID. 1 plus network ID is the first usable address. And how to define or how you find the last usable address? Just minus 2 from the next network. So the next network is 192.168.0.32. Minus 2 is 192.168.0.13. It is the last usable address. Broadcast IP address minus 1 from the next network 192.168.0.31. It is the broadcast IP address. It's the same procedure for the next networks and the next network and so on. So here we define 8 network with its usable address and broadcast address. Now we have 2 department in this scenario or in this topology. Again, it is a FLSM subnetting. We are not using because we have a lot of IP waste with the FLSM. We can assign any one of them in this topology. We can use either network ID 1, 2, 3, or 4. So in here we have 8 separate networks. In each network we have 30 usable IP address. Number of address in each subnet is 30. All the subnet have same subnet mask 225.225.225.224. Answer the given subnet questions. Which subnet does have 172.31.7 137/27 belong to? So as I told you before, if you wanna solve the questions within a second or within a 30 or 15 seconds, any question of subnet mask, it is compulsory to have a cheat sheets in your minds. So now let's refer to a cheat sheets. In which cheat sheets or which column of cheat sheets we can find the answer of the given questions. We locate at the 4th octet of a subnet or a binary. We locate at the 4th octet of an IP address. So in here, we just change the first 3 bits of the 4th octet into 1. Because by default the CIDR of a given IP address is /24, but we count until we reach the target 26, 20, 25, 26, 27. So it shows us that we have borrowed 3 bits from the 4th octet of an IP address. We can find that we are located on the 3rd octet of a cheat sheets and the group size is 32, the subnet mask is 224, and the CIDR is /27. Now let's start with 0 and increase it up to the target, or we pass to the target given addresses. And here we find that the given IP addresses belong to the 5th network ID or subnets, and the total IP address is start from 172.31.7.129 through to 172.31.7.158, and the 59 is a broadcast IP address. The next network will be start 172.31.7.160. Answer of the given question is host 172.31.7.137 as belong to 172.31.7.128. Next questions. How many subnet and host per subnet can you get from the network 172.22.0.0/21? So this given question that how many subnet and host we can get from this IP address. Again, we look at the cheat sheets. And here once again, we look at the cheat sheets in order to make our journey easy. But in this given IP address or this given questions, we are located at the third octet of an IP address. So let's check. So in this questions, I'm changing the 5 first bit of a third octet of IP address. The default subnet mask of IP address or a class B address is 16. So now let's count on until we reach on 21, 17, 18, 19, 20, 21. So we are in the fifth column of a cheat sheets. We defined that group size is 8, subnet mask is 248, and the CIDR is /29. Again, we start until we pass the target IP address. We start at 0 and increment it by 8. If we use a formula, first we find the network. 2 to the power of 5 is equal to 32 subnets. 2 to the power of 11 minus 2 is equal to 2046 usable host. So in here, we start from 0, we reach to the target IP address 248. So now the given answer of the given question is subnet is equal to 32 and host per subnet we have 2046. What valid host range is the IP address? 192.168.239.212/29. A part of. The given question is like, how many valid IP address do we have with the given IP address? So the process is the same as I told you. Again, we refer to a cheat sheets. So in this questions, once again, we change the 5 first bit of the fourth octet of IP address. So the fourth bit of IP address, the group size is 8, subnet mask is 248, and CIDR is /29. We borrowed 5 bit, 128 plus 64 plus 32 plus 16 plus 8 is equal to 248. Now let's find the networks, the usable networks, and the broadcasts and so on. In here, 2 to the power of 5 is equal to 32. With this given IP address, again, we have a 32 networks, but host is difference. We just left 3 bits in fourth octet of a given IP address. It means the 5 bits of fourth octet of IP address is changed to 1, and just 3 of them left as it is. It means 0. The 0 portion indicate a host portion, and ones indicate a network portions. So 2 to the power of 5 indicates 32 networks, and 2 to the power of 3 minus 2 is give us a 6 usable IP address in each networks. Network ID start from 192.168.239.0 and we increment it by a group size or by 8 until we pass the target IP address and the first usable address, last usable address, broadcast IP address. Easy way to find or define the first usable address, just add 1 to the network ID, last usable address minus 2 from the next networks, broadcast IP address minus 1 from the next network. So the answer of the given question is 192.168.239.209 through to 192.168.239.214. So these IP addresses belongs to network 208 and the usable IP address is 6. You're designing a subnet mask for the 172.31.0.0 network. You want to 9 the subnet with up 400 hosts on each subnet. What subnet mask should you use? Cheat sheet is awesome. Cheat sheets play a key role for an engineers, for a network engineers, in order to overcome or make easy answer to the given questions. So in these questions, we change the 7-bit of the third octet of a given IP address. So we locate at the 7 column of the cheat sheets. The group size is 2, the subnet mask is 254, and the CIDR is /31. So we add all these value of each bits of a third octet of a given networks: 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 is equal to 254. Now let's find answer of the given questions. To the power of 7, it is a 128 networks. It doesn't matter how many network do you obtain from the given IP address. The focal point is in the given question is about the host. We have to obtain a 400 hosts on each network. So the next formula is to the power of 9 minus 2 is equal to 510 hosts in each network. But we just needed 400 of them. So answer of the given question is the subnet we use for 255.255.254.0/23. The CIDR /23 is match to our requirement: 90 subnets and 400 hosts. Lecture review. In this lecture, we talked about VLSM, advantage of VLSM and disadvantage of VLSM, solving some questions according to given topologies, answer to given subnet questions. And if you enjoyed the video, if the video is informative for you, so thumbs up. And if you have some questions, please put on the descriptions below and comment. I will answer as soon as possible. Thank you for watching. That's all for this video. If you want to show your support, please subscribe the channel, like the video, leave a comment, and share the video with anyone else studying